Welcome to Study Loop.
Here we have a cylinder that is filled with presumably air, which is mostly made of nitrogen. We are simulating a car engine cylinder. So what happens first is that a lot of heat is added suddenly. So we have some gas here, and we are adding heat, so Q plus, to the gas. Also, we are keeping volume at constant, so this is V equals constant. And in this case, the heat and the temperature will be related in the next expression. So Q equals N, number of moles, times heat capacity for constant volume and the change in temperature. So here we have a constant volume process. This will be further equal to Q equals N times CV times T2 minus T1. So what happens is if we hold down the piston of the cylinder, the temperature will rise, but no work will be done to the surroundings. So all of the heat given will be going into internal energy of the system or to change the temperature. And we need to find what is the magnitude of the temperature, what is the T2. This is the unknown that we need to evaluate. So we can derive the equation for it simply by first rearranging this expression. So Q over N times CV equals T2 minus T1. And then this will equal to T2 equals heat over N times heat capacity plus T1. We know this temperature is starting temperature, and we know the heat added as energy. Also, we know its constants and the number of moles. So we can immediately substitute and say that it's 645 joules added into the system, 0.885 moles, times 20, this is a constant for most gases, moles Kelvin. And this goes plus 780 kelvins as well. So when we add this together in using a calculator, we obtain that the temperature T2 will be equal to 947.9 kelvins. So all of the heat that was added into the system was basically added to increase the temperature. No work was done outside of that. So on the diagram, pressure volume diagram, this is going to look like this. This is for the pressure, and this is for the volume. And we have two pressures. We have initial pressure, we have final pressure, and we have some volume, that is constant volume. So it will be just a straight vertical line from one point state 1 to point state 2. And for the part B of this problem, we have to solve for we have the same question to answer. What is the final temperature? But in this case, the pressure is constant. So the cylinder with the piston, this is usually a cylinder inside the automobile engine, is going to move. It's going to move up. And the gas will expand due to added heat. So Q plus. Now, in a similar manner, we can say that T2 equals, we will use already derived equation, we will just change the constant from the Cv to Cp. It will be Q over N times Cp, heat capacity under constant pressure, plus T1. Substituting the known values, we see that it is 645 joules. The number of moles goes here. This is the times. And the different constant value. This is joules per mole Kelvin, plus the initial temperature, 780 kelvins. And when we evaluate this using the calculator, we obtain that the T2 value is 899.9 kelvins. Now, obviously, this is a lesser value for the temperature T2. And why is that? Well, of course, because now we have some work done onto outside of the system. So the overall heat Q will go to increase internal energy of the gas in the chamber, but the chamber gas will expand and do work outside of the chamber. This work is then transmitted to the engine, and it is transmitted into rotational energy of the wheels, or it creates a torque or whatever it needs to create depending on the type of the engine. So here we are doing work outside of the system, and the temperature T2 will be lower than in the part A, when simply whole Q is going inside the internal energy and it's only doing the increase of the temperature. And the PV diagram, the pressure and volume diagram, is going, for this part of the problem, is going to be, this is P, this is V. So we have two volumes and the two states of the volume, so in the single state of the pressure. So in this case, the graph will look like this, from point 1 to point 2, the direction of the process. So the volume is expanding. And by solving this, we have solved the problem completely, and I hope you find this helpful and useful, and I hope to see you in another lesson.